So,
Cool.
a webinar. You've already been in the third week right now, isn't it? Nathan, help, please.
Yeah, so we're just entered module 3.
Precisely.
We've starting to get some assignments in for module 2. The first module was the quiz that we had. And so, yeah, module 3 is looking at kind of the same facade we've picked for the first main assignment, and then having a look at different materials of how that would come together. And so, yeah, in today's webinar, I mostly just put together your questions you had, Matteo, over the last week. So it's actually kind of just your questions in the webinar so far.
Yeah,
But it's an
very good,
open
actually.
discussion. So if anyone has more questions, it's what we're here for.
And he's from
Precisely.
Rotterdam, so we see a Rotterdam sample at the Luxor Theater.
Yes.
Yeah, precisely.
Yes, I've
We'll
called
share
it a
this
case
later.
study.
We will share it later here within the lectures or within the slides. But
Mhm.
for all of you joining, please also feel free to ask question while we're running this. We didn't receive so many questions in advance, so therefore, in order to fill this webinar, makes it more lively, would be also nice if you just throw in a couple of more questions, or we start a discussion afterwards if you like.
Cool.
Perfect.
So I guess we'll go into the first question, which was yours, Matteo. It was about what we do when we sort of have the window not within the insulation layer as we drew in all of our examples, but rather in the structural layer. So,
well, then first thing you have a cold bridge, so you have to overcome that. So that's a downer.
Yeah, I
and,
think
and
this was the. Sorry, go on.
Go on.
No, I'll show you what I responded with a few things that I knew, but I made the point that most of my detailing knowledge is from Australia, where there are just cold bridges. It's kind of poorly presented. So I'll show what I had, and then we can
have to be nitpicking. Being the educator here, it's not a cold bridge, as we also just tell in Germany. It's a cold bridge, but it's a thermal bridge.
Yeah,
so therefore,
you're right.
100 points would be thermal bridge for the answer. What is this?
Heat and cold.
Yeah, precisely. Yeah, this is, of course, if you have your facade in the structural elements or within the line of the concrete, for instance, or the masonry wall, then you have to make sure that it is for sure smaller, because you can't make the window smaller if the opening is not perfect. So that's what has to happen in order to make sure that the opening has the right measurements. Otherwise, you won't be able to make it back and forth. So it always has to be smaller in dimension. Usually, when you have it behind, within the layer of insulation, you can still move it in and out a little bit. Depends a little bit also what the overall view from the outside would be, but make sure that in this case you have measured everything, and maybe it's the most common is the smallest opening in the structure that defines the size of the windows, and then you can gap bigger bridges or gaps. Or you can bridge bigger gaps. That's the right one, in order to make it happen, that it fits. Nathan, what have you explained here? What was your line?
Yeah, so this is what we talked about in the discussion page. We spoke about sort of the detail of having a subhead head sort of system like this. Yeah, this is where I said this was more Australian detailing coming in. This is something that I would see quite a bit in my experience, but this is sort of the detail here, maybe a bit better.
Make sure, because we will also explain this detail in the MOOC. We actually have explained that in the stick system MOOC. That is the profile that will allow us to work with movements of the facade. Think about a large span opening for 6 meters or whatsoever, and the structural engineer tells us that there is a movement of the ceiling or of the beam possible. So then you have to make sure that you use a profile like that. Maybe you can go one slide earlier, makes it a little bit more clear in general. So the subhead is holding on to the window frame and allows movement, but these movements are from requirements within the structure itself. So therefore, you assume that there is either winter, summer temperature, or various of loads that the ceiling may have a flex in it, that it bends down. Then this profile will allow for the movement. It's not meant to be to overcome tolerances, because what you see here, the little silicon or the joint on the outside with the little circle that is most likely a foam insert, that's the area where the tolerances has to be taken care of. And the subhead has to have the movement you design or you chose for. So let's assume the structural engineer advises to have 20 millimeter movements acceptable within the facade top point. Then you can't just push it a little bit in because the tolerances from the building itself is not there, and you reduce it to 5 millimeter. Then in case of a load and the ceiling bends downwards, you have cracks in your windows because it's not capable of what you're asked for. So make sure that you take a distinct separation of movement within the tolerances you assume from the overall load-bearing structure and tolerances that might be due to the building process and someone didn't watch the measurements tightly.
As we see, there's differences between countries. So as you said, Nathan, your Australian background with maybe less difficulties with thermal bridges, while our Western European environment, where Marcel and me are mainly detailing, deal a lot with that kind of question, which you see in that other thing. There's a nice anecdote about the Dutch way of thinking this. Look at Marcel.
Yeah.
They actually place a window frame without the moving parts and the glass in the wall while it is constructed, which means they get rid of the tolerance problem by having the window placed and then the brick brought next to it, which I think is a smart way of doing, because then you have a soft part which is then hardening in process, which is brought to the window, and then you place the window frame with the openable parts later into it. Yes, you have to take care of the construction side and that say this frame doesn't fail or doesn't get harmed too much. But it's a nice way of rethinking this. Not something which we'd like to educate here, but which I'd like to address because it shows that there's different ways of dealing with certain things. In the end, it's physics and the logic. So you need to be able to get the window in your hole. And if that doesn't fit, you either change the window or you change the hole.
Yeah, for me as a bricklayer, this was really kind of like something I've never seen when I crossed the border, because the bricklayer actually puts the wooden frame onto the last layer of the stones, and then just holds onto it. Maybe there's a short temporary fixation with a piece of wood, and then he just puts the bricks to it, over it, and that's it. There's a little concrete beam on top, and then the window always fits because he just uses his stones
as a frame.
It's a very lazy way of building, but of course you eliminate all the tolerances later on, because when the guy with the window opening comes, it fits for sure.
Yeah. Okay, Nathan, next topic.
Next topic. So the next topic was an extension to this topic. It was just your question, I think, was what happens if it's timber, not an aluminium frame, where you can make this sort of these profiles to have this allowance. My answer was to another detail that I think was from New Zealand, in having, I don't know if you can see my mouse, but this sort of small gap, not taking the play in the gap rather than the actual system itself, was my answer to that. I think Uli, maybe you have a comment on that.
But you still need to deal with the tolerances. So the frame is done. So you see that gap between the upper timber and your window frame, and that's actually the tolerances dimension.
Yeah.
And say a rule of thumb, make it at least a centimeter. Better 1.5.
No, I think that's what we had the link to the building code in Australia, and it said it had by law had to be minimum 10 in a detail like that.
10 millimeters.
Oh, 10 millimeters, yeah.
Yeah. That's pretty much it. And imagine when you go to different materials, the wood may be adjustable on that level. But if you go for a concrete structure, regulations allow you Marcel, 3 centimeters on 5 meters,
Yeah.
kind of.
Yeah, plus and minus 3 centimeters, which is a lot.
Which is a lot. Which means that the window changes a lot by size. And what you showed here, Nathan, is the far left side. This is where the cover of the tolerances actually happens then in the outer view. The difficulty appears if windows start to jump in the construction. So if the tolerances are really maximized, 3 centimeters plus or minus, and you have them next to each other, you have to make sure that they align, because otherwise you're at some point going to notice that they're jumping by a position.
What's interesting, what we've also seen here in the Netherlands, for instance, if you think about residential housing, they use concrete floor slabs and concrete walls. So an entire room or the flat itself is kind of like this tunnel. There's also what they call it, a tunnel building system, where they cast use on site. And when they use prefabricated window elements as a window facade being entirely placed within the opening from ceiling to ceiling, so it's an infill, they used to use either an aluminium window systems or wooden window systems, but they add a piece of timber around the entire circumference of the prefab element that fits within the tolerance, let's say, often intentionally made a little bit bigger. And then the guys, while the frame hangs in front of the opening onto a crane, there's one guy with a chainsaw and he just rasps around and on the fly adjusts the tolerances.
That's a rude one, Marcel.
But that's what we've seen. So therefore, they sort of customize these wooden beams by ease on shaving away with a chainsaw while the element is flying in the air. It's kind of crazy idea. It's almost kind of like a cowboy's attempt. But they are very fast. And they are able to make it almost press fit into it, and then they just need a little bit of seam. Very fast way of doing it. I would not propose this as a standard, but I've seen it, and just by a little piece of wood, they can easily shave it on site to the tolerances of the opening that was done from the contractor. Yeah, really crazy idea. For me personally, I don't want to have a piece of wood in between the concrete and an aluminium facade, for instance, that in case of water damage will swollen and creates other problems.
Yeah.
Cool. Okay, does that somewhat that's kind of the similar answers to what we had, Matteo. Does that help to answer those questions we had? I think cool. Then we'll continue. The next one was also to just the level of detail. I sort of made the mistake of getting the numbers wrong in my head over the scales and sent you down the wrong track, I think, Matteo, but I'll put the two drawings together that I think sums it up well. So to bring you up to scratch, Uli, with Matteo's drawings, we just had the comment where I think the template made it quite hard to see the finer details at the overview. You'll see the drawings later. We'll talk about the detailing of that.
Sorry, Nathan, we have to do this.
Mm-hmm.
We have to do this. I'm in Delft at our construction site, which is this is a research lab of Alessandra walking there, and she's touring around a bunch of students. There they are. Here you go.
So now that will be also part
off you go. Off you go. I apologize for doing this, but
right. You're back in the office.
This is back in the office. Exactly. No, I'm back in the office. The office is real. The office is my office.
But Nathan, can you explain a little bit more, or Matteo, can you explain a little bit more the question you had? Was this about how much information is within the different scales?
Yeah,
of a detail?
It was like about the difference between like the 1 to 20 scale and the 1 to I guess 5 or 2 even. Like how much do we need to show, for example, the tolerance, the elements for the rain, let's say rain protection, or the all element of insulation that are added for the continuation of insulation. And in general, the continuation of this question more in the real life, uh, depending on who are we talking to, like the client,
Yeah.
the contractor,
Yeah.
level of detail do we need to use, and which information do we need to use for each stakeholders.
Yeah. Uli, you or me?
Yeah, I give it a start. The left one is a rather principle sketch to explain the geometry and the dimensions. The right one is a more detailed sketch, and it depends a bit on how fine you can draw and what kind of tool you use. So hand sketch, then it's limited, 1 to 5 on the right side, I think, and 1 to 20 on the left side, I think, which is a way of communication. If you do it digital, you can, of course, draw 1 to 1 and then zoom into, but then it's going to be so black and so difficult to read that the information maybe is too much. That's something which you need to calibrate depending on the purpose of the detail. If the purpose for the detail is to explain to your client how in general it works, you may go for a larger scale, the 1 to 10, just to explain how these systems work. If you want this for a contractor to use to manufacture certain things, maybe the 1 to 5 is not right, and you need to go to a 1 to 1 or even to a 2 to 1, so even larger. That pretty much depends on to whom you want to talk and which information you want to give. You can also imagine to describe all this by text, but sketches are a good instrument. And this is only two-dimensional. If you then go into a full BIM-based project or something, you may end up in a three-dimensional sketch, copying in the system suppliers' details in your details. And when you go this route, you need to be aware of then you're addressing to your contractor, oh, I want this system, which is not what you want to find the best price because they may come with different alternatives. So what we also sometimes do, Marcel did, is at some point you engineer the whole thing to the point. You know all the details. You may even know the sizes and dimensions of screws and types of screws and glass or whatever. And then you may, for the tender process, take information out to secure that the ones giving a bid do have chance to come with alternative solutions as well. So you may even reduce then the amount of information, prove that you're able to engineer completely, but then remove it to allow others to come with alternative solutions, which may be also good options which you like to see. Marcel, what do you want to end?
Yeah, that's what I've mentioned. We also used in our office with an add-on in AutoCAD called Athena. It's a plug-in for AutoCAD for facade engineers, makes drawings and details in smaller scales and bigger scales easier. In one-to-one details, you can draw directly a set of metal bended, and he does all the curvatures right with the right hatching and whatsoever. Insulations are easily dropped and filled in. So it's a pleasure to work with these tools. And they also have in the print module later on, the scale, which means you can define or use the defaults in which you tell this is a 1 to 10, this is a 1 to 5, this is a 1 to 1 detail, in order to make sure that on the printed paper, the line width are correct, but also the depths of the information is correct. Because you may want to talk to someone about the general modules for the architect in the early starts. He's more interested in where unitized facade ends. Is it above the floor plate? Is it underneath? What defines out at the very end his play of lines and the proportions of the facade components and so forth, while you do not need to give an exact information on the mounting brackets at the back or whatsoever in that discussion. So therefore, you always have to make sure that you are aware to whom you talk within the process of the time, what decisions to make, because often we also, when we come with too detailed drawings into architecture discussions where they are still not sure what the building will be, you end up in discussions on details that are not necessary and will actually mislead. So therefore, we often use hand sketches in order to make sure that the architect can focus on what we would like to discuss and not talking about hard or soft insulation or whatsoever profiles. So therefore, it's also a little bit how you prepare the meeting with the client or the meeting with the architect, the meeting with later contractors. It's a little bit depending also who you are. We as facade designers have worked for either contractors, facade contractors, so we made their installation planning, we made their planning that were sent to the architects to communicate the product. It's a different kind of view if we are on the side of the facade contractor. And on the other side, we have also helped architects being in part of that team by the very first sketches within the competition. And after a year, the competition was won. And then we sit next to the architect to try to make sure that all his ideas and especially the aesthetics of the design is taken care of within the details, which we have to then defend against the contractor who may have another saying or idea about how to make details possible because he wants to save money or whatsoever. And in between, you always have to ask yourself, who is receiving these drawings within the communication at the very end? Make sure it's as detailed as possible that someone can make a price on it if it's for the tender, for instance.
Question in the chat, Marcel, to you.
Yep.
Athena.
There was, Athena, it's for Autodesk AutoCAD. Athena is a German company that was a former facade engineering office who have specialized their own software applications and now support this, I think, in 6 different languages already. We even had a Russian module in it that you can, by clicking onto a button, switch the different languages. Be careful with that. Russian takes six times more word and text than the English or the Germans. Athena, if you look for it, Athena AutoCAD plug-in facade engineering, you will find a company. They are in Darmstadt, I think, or in Frankfurt based. It's not cheap. Back then, a license for one work was around 5,000 euros, but it makes your work so much easier and so much faster. And you also have an integrated insulation isothermic calculation. Each part you use is already on the correct layer that defines the materials, and you could easily draw a window, place a window or a rectangular over your detail and then hit the button for thermal calculation, and it shows you already a false color graph of your isothermic lines, and you know exactly if you have a thermal bridge or not. Quite a powerful tool. They also have a pre-calculation of depths of mullions for facade by bending.
Structure.
For structural parts, nowadays they work fully 3D. And they also have a huge library in that you can feed from Schüco, Raiko, Vicona. All the different companies have a plug-in into that. So you can use the latest profiles and products already from these companies to connect them together. Quite a powerful tool. If you don't know, have a look. That's really a pleasure to work on one-to-one details for facade sections.
Marcel, if I'm now an architect and I don't want exactly this kind of details from one of the standards, if I come with my own design to you, what would you do in Athena?
Now, you can draw everything from scratch in there too.
You need to draw it yourself. That's pretty much it.
Yeah, precisely. But the question is, let's face it, at the very end, you have to deal with standards. So you don't envision your own facade system, your own window systems. What we've often done is also within projects, when the project was big enough, you are allowed and able to design certain part of extrusion profiles that make your facade more customizable, more special, because of you can maybe integrate sunshades. That's what we did. The architect wanted a special framing around. So within the existing system, we could make customized extrusions that fit within the system. We as an engineering used already early 3D printing for that. So you can have a cutoff of an actually facade profile, and then our 3D parts next to it to make sure it fits, and then you can get to one of the suppliers and order these custom extrusion profiles. But yeah,
But that needs a certain size. Huh? You need
yeah,
a
of
10,
course.
10 kilometers profile or 5 kilometer profile.
You have to have the right amount of it, otherwise it will be too expensive.
Yeah.
There was a question also from looks like a design for curtain wall, not ventilated facades. Now, in general, you could also do classic ventilated facades, even standard windows. What I actually liked is, for instance, the opportunity to make a drawing, let's say horizontal section through a wall with the two joints left and right of the window profile, and then you cut off at a certain point of the insulating glass because you do not need more to draw, but you can already measure the outer frame's measurement, and you say this measurement is 1.25 meters or 1 foot whatsoever in American measurements, and then whatever you move and change is already within the two systems, so you can actually measure the entire window while you haven't even drawn it. It's in a, like we have here in Uli's left section, the zigzag line means there is a short piece cut out because this is just boring. You have the bottom detail and the top detail, and in the middle is just 1.20 meter glass. You don't need to show that. You just squeeze these together. But in Athena, you can still say this is a 1.80 meter high window, and everything else is also measured correctly. Quite interesting. If you then fiddle around and you move things, the window changes is actually synced. Have a look. Give them a call. Great product. Works as a add-on for AutoCAD.
Cool.
Next question.
All right. The next question is,
Ta-da!
any further questions?
Oh, yeah.
Come on.
No, so
Come on,
we will still go through
Uli,
the.
take care. I will try to find a link.
Yeah, I'm trying to. If I join from my other computer, I can send the link. I think I have it here.
I will also do
think
this.
Marcel is already active.
Oh, perfect.
Yeah,
Marcel is already active.
I'm
Cool.
at copy. It's here. It's maybe it's actually good to also talk to them. I maybe know people from there still from my back then, because this might be also interesting for one of them. Then, if we think about new MOOCs,
Yeah, you're right.
this is very interesting because it makes your life so much easier. We have never mentioned that we still sketch for you in order to make sure it's understandable. But the more deeper we go into detail, we have to share also software applications and so on. Actually, Schüco, Vicona, Reinhardt, they all supply also all the detail digitally, which of course makes a good starting base to start detailing. Even, and that's what I often did because the software is so easy, you puzzle together your details, your window frames and whatsoever based on the assumption what you think might be the best choice. And then I just take the outline. A pro would still identify those, but not the architect. And then you go with these simplified drawings to the architect and to the discussion, or I sketch over it just to make sure it's a sketch, because you don't want to run into detailed discussion in the first beginning of the project. But then I know already this is possible with this sort of systems, which allows me fire safety and airtightness and whatsoever, and that I'm able to continue later on to talk about the companies and contractors that this is possible.
I think also
can you tell a bit about, say, this is now the engineering software to use, and then this is transferred into contractors or system suppliers software. What happens there, and why is this software different, and what does it do with the machine process?
Yeah, I especially worked till a very young guy, a little boy. My best friend's father had a company who made windows, winter gardens, facades for Schüco. So I have aluminium splinters in my blood, literally, because I cut myself once on a saw over there. So they used also software from Schüco, but this is a system within its own. So therefore, That's a little bit like kind of like buy Apple. If you keep continuing using everything from Apple, everything within the system is easy. The moment you want to share your agenda with someone who uses Microsoft or another platform, for instance, then life becomes a little bit more different. So you have to think about that. Athena is is an independent company who makes an input file or an input path from all the various companies to get their catalog integrated in your program, so you can pick from the world market of suppliers. They also have Fisher and Hilti wall mounts, brackets, screws, whatsoever. Funny thing is, for instance, if you take a screw, a self-tapping screw, 6 by 100, and you see it doesn't fit, you can take the little side points and you can pull it, and then it springs to the next available measurement, 120, 150, 200. In between, if there's nothing in between, this screw is not available. Means that you can't even come up with screws that you can't even order. Quite intelligent. But if you're, for instance, using software it's from one supplier, I mentioned Schuko because I have experience with that, then they will not allow you to add any other screw you may get from Fisher, you may get from Heco or from other companies, because they want to sell their own Schuko screws. For sure.
You're stuck in system. You're stuck in
the system. Then it depends a little bit what you do. If you are a facade contractor, you build facade window frames and whatsoever. You are well done when you have the machines from the company that is provided. Schuko sells their own CNC milling machines. They sell all the equipment, the machines you have to have for making windows and facades. Then everything is almost flawless. The moment you have to work on a different profile, you're almost doomed because they doesn't fit in the system or you don't know how to set them up. But this is if you're a facade contractor and you're running the production. As an engineer, you don't have to deal with that.
You don't want that. You actually don't
want that. What we also had that we, for instance, work together closely with the object managers that help for technical details with the various companies, either Schuko, Varema, Reinhardt, Varema, something like that. They also help you as a facade engineer to find the right solutions, but then at the very end, make sure that you are the one who controls the details and have the power of editing them, that you are not bound to them because they didn't hand over only PDFs and not DVGs, for instance, if you work in AutoCAD.
Yeah. Thanks, Marcel.
Well, we still have 20 minutes, and I still have more questions that are from this, but so this is Matteo's project. He had picked the Luxor Theatre.
Yeah,
and I've tried to summarize all the questions into one, and I figured maybe it's just best if you two can talk about the details because I couldn't answer them in the discussion. So these are your photos, Matteo?
Yeah.
And then I've summarized kind of some of your questions, but you might have more, I think.
Yeah. Basically, we talked a lot about insulation continuity and cold bridge or thermal bridge, whatever. And in this facade, it's like a free-form facade. I mean, at least single form curved facade with a boxed window.
Yeah.
So kind of like the Frank Gehry image from Düsseldorf. That's why I took this project to test out detail from this. So actually, the main question is how do we deal with tolerance and insulation continuity, plus also water tightness when you have like a huge steel profile that goes out of the facade and has like 15 centimeters from the window insulation to the actual insulation, and how you deal with this gap in terms
And
of.
we see the detail you drew. Nathan, I'm sure you have it somewhere.
This one?
Yeah, this one. So this is what you assume this is made of. Okay. And we see a timber cladding at the outside. We see a substructure. Then we see an outer layer, insulation, an inner layer, gypsum board, I guess. And then you drew these boxes. And the top part of the box, drainage, is taken care of with a metal sheet. Okay. And then there's this shading device which is integrated. Are you sure this is existing, or how do you know? Did you go inside? Have you seen it?
I've seen something that was hanging in front of the. I couldn't go in; it was closed.
Yeah.
Hanging behind this, so I assume it was some kind of shading device, but I'm not sure, to be honest.
Because as you've drawn it here, it's obviously again some kind of thermal bridge, because you have a part where the insulation is lost. That's a building of what, 1990s, 2000-ish. So insulation was already an issue. So I would believe that they find a solution to at least have this blind a bit smaller, so that there's maybe insulation, but some insulation left. Side note, if you do that, if you change dimension of insulation that intensive, you may end up with humidity in the cavity because dew point appears, and then maybe that would be a risk. But okay, just having said so, and then we see the window being placed quite outside, but that's in principle the way I would design this as a setting. And if I'm not mistaken, we also saw some similar things with the Gehry buildings in Düsseldorf. They look very slender as boxes, but that's a design issue. They also have this insulation circling around.
My question as well is, what structurally, what would be happening here, if you can see my mouse?
Yeah, for sure. There's some.
We would just have some sort of struts coming straight out.
Exactly.
Cool.
Because the upper and the lower part will not carry the load. Or you build a real sandwich, but I don't expect that to be done in that building. Marcel?
Mm-hmm.
What I'm curious about, and this is not maybe taken into account in this detail you draw, is how it is assembled actually.
True.
So what do you pre-manufacture? I would say if that is my project, I would make sure that I can deal with already subcomponents to be pre-assembled to bring to site. And this could be maybe the entire box.
Yeah.
So this would mean that you have sort of an opening horizontally, fins coming out the box out of it, and then you some sort of make the window inside. That might not be the case. That might be actually made in a different way, that a pre-assembled window frame comes in front of it, and then you later fit the overhangs and the inside cladding with insulation. I don't know exactly. Could be also a little bit different because of mounting assembly orders.
I agree. And then tolerances obviously is the interface is between the main structure and then the box, which you need to deal with as tolerances.
Cool.
Clear.
Well, I hope you don't mind me bringing up your project, Matteo. I think it's cool. I think it ties kind of the course together, because we had the punched windows in the first video, but we didn't really talk about them, and we won't throughout the course. So I think it's a good opportunity. So I think it's cool. I hope you don't mind me sharing your drawings, Matteo. I'll stop sharing because I think you have the question. One more question, and I'll try and open.
There was also a question from the lesson number 1.
Yes, I'm just trying to.
It was mentioned that there was, I think Nathan and I discussed this also within a fewer internal discussion. Is that maybe the same? That because there was one detail we have exchanged later on. Is it that because maybe that here is that the airline, so the airtight line of defense made no sense. Do you have a screenshot from the lesson? You can. I'm
trying to open edX, but edX seems to not be working at the moment.
I can bring it up. Hang on.
Perfect.
Cool, that'd be great if you could.
I need a second here.
Yeah, I can allow sharing or something.
Precisely, Nathan. Make sure he can share that. Might be also a good point if there's really a boo-boo in there that we can directly make a notification and change it later.
Getting there.
No, that's right.
Okay. Let's see. Where's the sharing? Let's see. This is the hard part.
Underneath the Zoom is the green button in the middle of all the buttons. Share.
Yeah. Can you see my screen?
Yeah, we can see.
Perfect. Yeah.
Okay.
Oh, you already have it in AutoCAD. No, is it AutoCAD? Yeah.
No, this is Bluebeam.
No, it's okay.
Yeah. So this is the air ventilation, air tightness vapor
Yep.
barrier. To me, right down here, makes no sense. I don't even know how you do that, what it's doing, and what it means. And then also, I mean, as a side note, on the questions on the test, and I missed this part. This was confusing, the wording, because it said which one, so I only picked one. And so I thought that this this line is incorrect because I just assumed it was straight. But then when I got to the answer, it said incorrect, which, oh, I'm sorry, C. I thought C was supposed to go all the way out here based on what you were sharing before.
No, I see the error.
Yeah, and then it says
Yeah.
correct C, so I'm like, well, I got the answer right, but you're telling me I'm wrong, so I was
Yeah. No, I see the error. It's the question has a it's
yeah. So
the question is
I didn't
wrong.
even
Which one
I
of
didn't even
these multiple answers apply? Yeah, it's
and
it's
I didn't
worded
even
wrong.
see this until the answer, so I'm assuming both lines now are incorrect. But my point being is that I didn't understand like I understand the water line and I understand the thermal line, but I don't understand this line at all because at least in the
Yeah.
United States, what we do, shoot, hang on a second, I'm just moving buttons around. So on we have what we kind of consider, I would say this line more or less here is kind of like what we would consider the
The
vapor
vapor barrier.
barrier and and so we kind of go in here a little bit and
Yep.
then we also go, more or less, down here. That's kind of like the water line and the vapor barrier.
Yeah.
So I
Be
understand the
careful.
general. Go ahead.
Yeah. First of all, sorry for making all of these lines yellow. This is on our list. That was actually I was hoping it was this detail because Nathan and I discussed this a couple of weeks ago, and we said we shouldn't change it within the game. So therefore, in the future there will be different colors. Maybe we also have to unveil that Uli is colorblind. But that's a side note. So sorry for that. But in your case, the orange line, we assume that the window profile, this might be out of wood, that the wood itself is already, let's say, water or vapor tight. So therefore, the watertight or the vapor tight, airtight layer is on the inside and not on the outside. So in order to make things a little bit simpler, we would say the outside is when the rain hits, you want to make sure that it is all tight and sealed. That's what you already understand, and that's also right. That's why we also have it running down the sill and drops over with the overhangs. That's it. Insulation line is the same. If you do it within an isothermic calculation, you would see the lines being narrowed down to the insulation glass, and then it spreads out because wood, for instance, would distribute the warmth or the temperatures in the bigger element. Aluminium can be a little bit tricky where the line goes, depending on the layers of the thermal barriers. But the inner airtight layer or vapor open layer is what we assume most likely to the inside of the window profile, covering the little insulation that gaps the wood profile with the masonry or the load-bearing structure underneath, and then into a little bit of the window sill. Assuming that the overall wall is already vapor open and or airtight, because you don't add with another film or coating all over the wall. So therefore, the turquoise or green layer dotted line is a little bit too far away drawn. I would say they stop because at the very end, your render on the inside, your gypsum board somehow does that. Or if you have a skeleton structure, there is a
Different
film.
story. Different story. Yeah.
There's a film on the inside. It's a little different story. So therefore, the vapor line or the airtight line is then on the inside, making sure you gap all the various openings where the metal or the window frame joins the insulation layer / structure layers that you have filled it, and then either taped.
Is the turquoise line an actual product or an actual
No.
additional layer?
It's just the solid structure. So you actually also could draw it in the solid structure, as the solid structure is creating the vapor barrier. That's how it is meant.
Yeah.
And we separated this to make it clear that these are separate lines.
You mean there's essentially 3 lines of defense: the water.
Exactly.
Yeah.
And so I believe, if I'm not mistaken, in the United States, the water line and the vapor line are the same product. And we use
sometimes could be.
We typically like in this particular situation, we would have.
I actually would worry about that.
Yeah.
Because humidity comes from inside, then penetrates your structure and stays in there. And the water from outside, you don't want to get into your structure, which means that then the vapor and water line is the same. It's actually at the outside, which means humidity gets in your entire structure, which I would not feel very comfortable with.
Yeah, there is sometimes, and that's the question, how you design your house. If you have a vapor open construction, then it happens naturally that you are able to do nothing on the inside because you assume that the water and vapor will, over the seasons, regulate itself. But think about a window, for instance, in a bathroom, and you have a hot shower in a cold winter day. If you have a thermal bridge somewhere, the water will condensate at that cold point within your structure, somewhere within or next to the insulation, and that may harm the structure from inside. So you want to make sure that you have a more vapor-tight barrier on the inside and a more water-tight barrier on the outside. So if you look at what is Widerstand? The resistance. The resistance of the internal pressure of the water is always that vapor can transmit outwards and is not catched up inside. So if you, for instance, look at companies like Ilbruck, they make 2 different tapes. One is used on the outside, which is capable of having more a direct rain protection sort of thing, but still lets vapor from inside to the outside, while another tape on the inside, window profile around the corner, for instance, that allows humidity to pass by from high pressure, let's say, showering vapor. It's hot. That is allowed to evacuate through the system then. So it's a little bit difficult based on various products. We can also see there is on the outside, for instance, these self-expanding foams that replace a tape strip because it also allows vapor to exit. So
the question I have though is that I'm still confused because what you're telling me is this line right here. Could that line there, you're saying could be essentially here, right?
No, in the material itself, not
in the middle of it, let's say.
Exactly.
Yeah, like that.
Like this, yes.
Yep.
And then the material itself, the solid wall, acts as a vapor barrier.
Right, but I'm in my head I'm trying to figure out what's the difference between that and then what I've drawn here with vapor barrier, because this is the air and water vapor barrier, and I still have my wall here. Just to me, it seems like it's a theory, not necessarily a product. Is that what you're saying?
Yeah, it totally depends on if you have, for instance, a window opening in a concrete wall.
Yeah.
It's a total different application than a window opening in a skeleton wooden stick system where you have to use a film on the inside to make the entire structure vapor tight. So therefore, if you're only dealing with a punched window facade in a concrete building, then you only need a little tape that covers the edge or from the inside. That's it. If you have a skeleton structure, classical wood timber structure, which is then has to use a film on the inside and also tape all around to make sure that no vapor is coming out, then that's an actual product.
Okay.
What is your experience, and in which field do you work?
We provide ventilated facade solutions for companies, and it's exclusively commercial buildings, hospitals, museums, things like that. So it's all commercial. And so this orange line here, it's always, I mean, I've been doing this for 12 years, and they call it the AVB layer, the air, vapor, and water barrier, or AVW. Yeah. And so it's
One
always
fits all.
Yeah, and they just it's a peel and stick product. It's either applied by a big
tape,
roll.
no?
Yeah, it's a peel and stick.
It's a peel and stick big roll, or in some cases it's a spray on application. That's very rare, but generally it's a peel and stick, and then your flashings and all that. There's another layer of flashing, and then another peel and stick that ties into it, and so.
What's then the inner wall? What's the material of the inner wall?
Well, the inner wall, generally speaking, it's dense glass, and then metal stud framing.
Yeah, and then gypsum board then inside.
And then gypsum board on the inside. Yeah.
And where stays humidity, which comes from inside, which then stays or ends at the sticky tape? Where does that stay in the insulation?
Well, the insulation is on the outside of the vapor barrier, so the insulation stay. So
yeah, then we're talking about the same. Then we have an inner layer which covers, which is statically, which is the gypsum board. Then we have the protection of humidity getting in the structure, which is this stick and tape. And then we have the insulation, which is outside of the inner humidity, which is necessary. And then there's an whatever kind of cladding at the outside to cover the whole thing.
So you're actually so you're saying that the sheetrock is actually providing a certain level of defense. The gypsum.
No, the gypsum board not, but the stick and tape. That's actually doing the airtightness.
Oh, gotcha. Okay.
And by that, the story you're telling is the same as ours. You only have a gypsum board as an inner aesthetical surface. Then there comes the vapor barrier, which is on the stud system. Okay. Then there comes the insulation at the outside of the vapor barrier. So humidity stays inside, is not penetrating insulation. And then there comes what kind of cover at the outside, sheet metal, whatever, to cover the building, which is then the water layer, which protects against direct rain into the insulation. And that's exactly the same story as the one we tell.
Well, I thank you. I've got a hard stop at 11. I got a meeting to go to. This has been enlightening, and I look forward to the next meeting and continuing the coursework.
Yeah, we see each other in a month's time. Great.
Yeah, okay.
Thank you.
Hopefully I'll be caught up by then.
Thanks. We will make notes, because of the moment the construction system changes, the layer of the inside layer also changes a little bit. So maybe we also have to clarify that in general, because it's a little bit unclear as you already mentioned. Thanks for that.
Yeah.
And I'll fix the question and upgrade or update your grade.
Okay, thank you. I haven't been tested like in 20 years, and I just like
can
lost
you
my
imagine?
mind.
Okay.
I'm like, oh my God. I'm like, my kids are my kids are going through school and they're mad at their instructor, and I'm like, what do you guys?
Yeah.
What's your problem? Just take the test and move on.
You'll be tested now.
It's a
Okay,
pleasure.
thank
It's a
you.
pleasure.
It's so often that we are somehow in the middle of filming and discussing this, and then a colleague from outside, company owner with the project we are front of says, but you should also mention that and this and that and this. Is yeah, we know, but we only have so much. So therefore, there's
7
so
minutes
much
per piece.
so precisely. But this is a point we have to make clear, that is either no yellow lines at all, or at least different colors, and make sure that we describe it well. We try to avoid naming products.
Oh, sure, I
this,
get it. Yeah.
In this case, it's tricky because everyone knows the blue film and the sticky foil and whatsoever. What is what?
Yeah.
Okay, thank you.
Thanks.
See you in a month's
Bye.
time.
Cool. That's no more questions from anyone else, I assume. I guess we're
You're
at
done.
6 o'clock now anyway, 6 o'clock where I am.
Okay, then Nathan, we stop filming and continue in a month's time.
Perfect. Is
A
it a
month's
month's time? No. It's only, this is
No,
week
it's
3 and they only have 6.
Okay.
In 2 weeks or so, I
it's maybe
think.
2 weeks. Okay.
Yeah,
okay.
precisely, in a month's
Okay.
time.
I'm going to be at a
Hey.
different construction site.
Cool.
Hope this was fun, helped a little bit, also helped us sharpen our exercises for the next time a little bit better. And keep doing this. This is fun. See you in 2 weeks if you like.
Great.
Thank you.
Perfect.
Thank you all.
Thank you.
Bye.
Bye.